Here's another example on solving a quadratic inequality using algebra. So step 1, we want to write the inequality as an equation. And then before we move on to step 2, we want to get that into standard form. So we're going to go ahead and subtract 2 from both sides. So now the equation is in standard form, set to 0. So we're going to factor it now. So we're going to use our diamond. What are the factors of 8 that add to -6? And that's -4 and -2. So we factor it into our two binomials. Then we use our zero product property. We set this first factor equal to 0. And we solve it for x by adding 4 to both sides. So the second factor equal to 0, solve for x by adding 2 to both sides. So those are what we call our critical values. So then we graph those on our number line. I call my critical points, my CPs. And then I need to test. So my inequality, remember, was x squared minus 6x plus 10 greater than or equal to 2. So I'm going to test a point of 0, 3, and 5. So let's start with 0. So we substitute 0, and so it's less than 2. So 0 squared minus 6 times 0 plus 10 greater than or equal to 2. And then we simplify it. Is 10 greater than or equal to 2? That's true. So we put a plus symbol there. Then we substitute a number in between 2 and 4. So I chose the number 3. And then we simplify it, and we get 1 greater than or equal to 2. Is that true? Is 1 greater than or equal to 2? No, that's false. So this interval is all false, so it's a negative. Then we test a number greater than 4, so I chose the number 5. Sub it into the inequality. Simplify it. Is 5 greater than or equal to 2? Yes, that's true. So you put a plus symbol there. All right, so I'm just going to draw that number line one more time. And we have 2 and 4 were our critical points. We had a positive, a negative, and a positive. So we want to write our solutions. So those solutions are where it's positive. So this solution is true, and that interval solution is true. So our solution then is -infinity to 2 and from 4 to +infinity.